Hi everyone, my name is Raylan Stokes and I work for the USGS Astrogeology Science Center in Flagstaff, Arizona. And today I'm joined by a colleague of mine, Ryan Anderson.
Hi everyone, I'm Ryan.
Ryan is a planetary scientist at USGS Astrogeology. He is currently working on the ChemCam instrument team on the Curiosity rover mission exploring Gale Crater. He's also a member of the SuperCam instrument team for the Perseverance rover, which is currently on its way to Jezero Crater, Mars. So today we're really excited that you joined us, Ryan. We have a couple of questions for you leading up to the landing of Perseverance.
Okay.
So our first question, can you tell us about the SuperCam instrument on Perseverance?
Yeah, so SuperCam is, as the name might indicate, it's the successor of ChemCam. So ChemCam is an instrument on Curiosity that uses a laser to zap rocks at a distance, and it makes a little tiny spark, and then it collects the light from that spark and can use that to tell what the rock is made of. SuperCam is similar. It has the same capability to zap the rocks, but it also has a different mode where it shines the laser light on the rock, and it can use that to measure what minerals are there rather than what atoms are there. So you can tell the mineralogy and the chemistry with one instrument. SuperCam also does infrared spectroscopy and has a color camera instead of a black and white camera. So it's sort of a Swiss Army knife of an instrument. It can tell you all sorts of things, and it's a nice way to explore our surroundings from a distance before getting up close and doing more with the rover's arm and more complicated things.
Wow, well, it does sound like it was rightfully named.
Yes.
So, can you summarize some of the biggest discoveries that ChemCam has made during Curiosity's mission so far and how they've changed our understanding of Mars?
Yeah, so ChemCam is it's a really useful instrument because instead of having to drive the rover over and reach out the arm and spend overnight or a day drilling or measuring right up close, we can zap rocks from a distance. We can zap several rocks each day, and each rock we zap, we hit 10 to 16 points on it, and each point we get 30 spectra. So it brings a ton of data in. And it's a really great way to explore the rover surroundings, get a quick look at the chemistry. And it's also really nice because it targets a pinpoint. It doesn't measure a big area, it gets very, very precise. And so we can measure things like chemical veins where there are special minerals that have been precipitated from the water. We can shoot really small things, or we can just shoot across the surface of a rock and see how it changes over a distance. And so by collecting all this data every day, we've been able to find some cool things. We found some really interesting minerals. So ChemCam was the first instrument on the rover to detect the sulfate veins we've seen all over Gale Crater. It also has found some places where there's manganese, which is sort of a weird metal that people are not familiar with, but manganese really only gets concentrated when you have conditions that are known as oxidizing. So that's not what we expected for ancient Mars, and so we're trying to scratch our heads and understand what that means for what the environment was like. More generally, we're seeing all of these different little veins and little interesting areas of chemistry, areas with really high silica. These all tend to point back to water interacting with the rocks, water transporting chemicals from one place to another, depositing them in concentrated locations. And so with all this data from ChemCam, we can watch how the chemistry changes over the mission, and we can measure these really small features. And all of that is indicating that, at least at Gale Crater, and we think we'll probably see something similar at Jezero Crater with SuperCam, is that the water has been interacting with Mars, and it's happened multiple times. It's not that it was just wet once, it's that it was wet and then the rocks solidified and then it fractured and more water came through and then it fractured again and more water came through. So it's this complicated story of repeated cycles of water interaction rather than just one time a long time ago when it was wet.
Wow, so ChemCam was definitely a busy rover and has set Perseverance up for some success, sounds like.
Yeah, we hope so.
So what are you most excited about for the Mars 2020 mission?
Oh, a lot of things. I mean, it's an exciting mission overall. I think for me, the most exciting thing is just getting to see a new place on Mars from the ground. You know, I was lucky enough to map Gale Crater before we landed there, so I knew what it looked like from space, and then we got to see it on the ground. And now, having done similar work at Jezero Crater, you have your ideas coming in from orbit, and then you land on the ground and you see what it looks like from the ground. And that's super exciting. But it's also a really exciting mission because it's the first step toward sample return. The Perseverance rover will be collecting samples of rocks and soils and storing them on the surface of Mars for a future mission to come and retrieve them and bring them back to Earth. And so it's really exciting to be part of the team that gets to pick those samples, gets to make all the measurements with the rover instruments like SuperCam that will provide the supporting information to put those samples into the geologic context so they can be useful when they're returned to Earth, and can really answer some of our big questions about Mars that we can't answer with a rover that's up there. We have to bring them back to the lab. So it's really exciting that this mission is the first step in that process.
Awesome. Yeah, there's a lot to look forward to. So when Perseverance lands, you're going to be supporting 2 rovers on Mars. That seems like a good problem to have, but how are you going to manage?
It's going to be a little bit crazy. We're still figuring out who's going to be living on Mars time when, and who's going to be doing what when. The nice thing is that it's a big team and everyone has their own specific roles, so no one has to be on all the time. You participate, you do your role. I usually do downlink for the instruments, which means I look at the data as it comes down from Mars and flag things that are interesting. But I don't have to do that 24/7 for both rovers. I do that every once in a while for each rover, and so for the most part it should be manageable, I hope. We'll see how Mars time goes, but we just had a meeting today where it sounds like we won't necessarily all have to be on Mars time all the time either. So we might actually be able to get some sleep as well.
Well, we are certainly excited. Looking forward to Mars 2020 landing. It's coming up soon now, and definitely appreciate you taking the time to talk with us about some of your experiences already on rover missions and what you're looking forward to with Mars 2020. So with that, I'll say thank you, and thanks to everyone who listened to our interview. And if you have other questions about what's going on with the Perseverance mission and how USGS Astrogeology is involved, we do have some other interviews that we've conducted with our team members. So you'll have to check those out on our page as well. And thanks everyone for watching. Thanks Ryan for your time.
Yeah, bye everyone.